Alright, hello everybody. Today's lesson is going to be on graphing transformations. And we're going to focus on the amplitude, period, and frequency. Now, one of the things that I noticed in class was that some people were wondering, where was I getting the information from? These are some things that you just need to know. One of the things I asked you to do was memorize the sine curve and the cosine curve. So let this one be y equals sine x. You need to know that it starts at the midline, it goes up to 1, comes back down, intersects. So we'll say this is 1, this is -1 here. Has a minimum, and then it comes back up. This is basically what the wave looks like. These points right here are 0, 0. Right here it is pi halves 1. This one is pi 0. This point right here, the minimum, is going to be 3 halves pi -1. And this point over here is going to be 2 pi 0. You need to know that the period, or the time that it takes for a full wave, a full cycle of this wave, the period is 2 pi. You need to know that the amplitude, which is the distance from the midline to the peak, this distance is 1. See, 1 minus 0 is 1. And that the frequency is 1 over the period, or 1 over 2 pi. And what does the frequency mean? The frequency means that you get one wave in 2 pi. Right, now the cosines are just, like I said, things that you just need to know. So when I refer to the period of the original curve, I'm talking about sine x and I'm talking about cosine x. Where did I start? 2, 2. Alright, I'm calling this one 1, I'm calling this one -1. The cosine curve is different because it actually starts at the maximum. The sine starts at the midline, the origin. The cosine starts at the maximum. And then it comes down and intersects. It has a minimum. And then it comes back up. And then it rises again to the top of the next wave. And the points then become 0, 1. Pi halves 0. This point right here is pi -1. This one is 3 halves pi 0. And then it's 2 pi 1. And the same thing, the period is 2 pi, the amplitude is 1, and the frequency is 1 over 2 pi. Alright, now that we've established this, let's go ahead and graph. The first thing that we're going to talk about is the general form. The general form for a sinusoid is y equals, or f of x equals, a sine bx plus c plus d, or y equals a cosine if we're dealing with a cosine curve. How do you know when you're using sine or cosine? Well, if it looks like the data is starting at the midline, then we're going to use sine. If it looks like the data is starting at a maximum, then we're going to use cosine. We're going to try to fit it to a cosine. But right now what we're going to do is, if I give you a function, I want you to be able to sketch it. The hard part, or the application of it, would be if I give you data and you try to fit it to one of these functions. That would just be additional steps, which we are going to do. Right now, let's talk about A, B, C, and D. We said that A, constant A, is going to, number 1, affect the amplitude. It is the amplitude. The absolute value of A equals the amplitude. And when A is not 1, oh boy, what do I mean by that? If you look at y equals sine x, look right here. That's where the A is supposed to be, but it's technically an understood 1. So when A is not 1, so if A changes, put parentheses on these, not parentheses, quotations. If A changes, the y values change. Now, the other one that we're going to talk about is B. B affects the period. Remember, right now in the original curve, B is 1. We can calculate the period because the period is 2 pi over the absolute value of B, and the frequency is 1 over the period. Let's see. And normally you want to end up with 2 pi on the bottom when you do this type of calculation so that it makes sense physically. If B changes, that means if B is no longer 1, two things have happened. The period has changed. X values have changed. Alright. Let's do this. Let's start simple. Let's sketch and get info for y equals sine x and y equals 2 sine x. Right? So y equals sine x from memory. We know it's going to start over here. We call this one 1. We can call this one 2. Negative 1, negative 2. We know it's going to peak at 1. It's going to come back down. It's going to peak down. It's going to have a minimum here and here. And we can call these points 0, pi halves, pi, 3 halves pi, and 2 pi. Alright, these are points for the sine curve. Now, we know the amplitude was 1, we know the period was 2 pi. Now let's talk about y equals 2 sine x. Well, what do we know from this curve? We're looking at it, we know that the amplitude is 2, so it's going to be taller than sine x. What is the period? Well, let's see, b didn't change. B is still 1. The number in front of the x, the understood number in front of the x is a 1, so the period is still the same as regular sine x. What's the period of sine x? The period is 2 pi. We established that at the top of this page. And so what is the frequency? Frequency is 1 over the period, or 1 over 2 pi. This means that we get one full wave in a period, in a span of 2 pi. Well, this is the same information as the regular x. The fact that b didn't change tells us that the x values didn't change. The period stays the same, the x values stay the same when b remains the same. So technically, we already have our x values for y equals 2 sine x on our graph over here. So it's going to be the same x values. What's going to change is the y values. Y values change. Right, because the amplitude is bigger. So the curve, the maximum is not going to be at 1. The maximum, the new maximum of the second curve is going to be at 2. Minimum is going to be at 2. It's still going to cross the x-axis here. It's just that it's going to go higher when it's time for the maximum and lower when it's time for the minimum. So, still going to cross at 0 where it's supposed to cross at 0, but it's just going to go lower and higher. And there you have it, students. Y equals 2 sine x. And the one that's lined is equal to y equals sine x.